Students, welcome to the sixth part of our fourth module, and this will be the final part in this module. So here we will learn about refrigerant leaks and their refrigerant leaks and their detection So refrigerant leak is a very important topic considering the VCR system. Why? Because leakage of refrigerant from a refrigeration system affects the performance of a sealed system. Okay, so basically the system is sealed. So there should not be any leakage from. There shouldn't be any leakage from or to the system. Okay. Okay, if there is any leakage of refrigerant, the performance of the system will be affected adversely. Why? Because if there is leakage, from the system, that is refrigerant being leaked to the surrounding or the atmosphere, what happens? Both suction pressure and discharge pressure get reduced. Both get reduced, right? So both suction pressure, uh, because of the refrigerant leakage, falls below atmospheric pressure, and what happens? Then there is a possibility of air leaking into the system. Okay, so if suction pressure is reduced below the atmospheric system, there will be a chance of leaking of air into system. This air will bring moisture along with it into the system. Then what happens? This moisture will get frosted. Okay, this frost will start to block the passages or pipes, so that it will form an obstruction for the refrigerant to flow. So if obstruction is formed, then there will be pressure drop, and all those things will adversely affect the system performance. Okay, so it is very important that the suction pressure should always be kept higher than the atmospheric pressure, so that there won't be any leakage of air and moisture into the system. Okay, so if there is leakage from the system, another important negative effect is that there will be less liquid and there will be more flash gas. Less liquid and more flash gas. Inside the system. So that is having another negative effect on different components of the system. Okay, so these are uh, the grievances that we have to address if there is a leakage from or to the system. So now we will have a look at different methods to detection of leakage. Okay, so first one is bubble solution. So here it is the oldest method of leakage detection. Here we will apply some soap solution. Soap solution is applied at some suspected leak points. Okay, there will be some suspected points where leakage is happening. So you just apply some soap solution with some squeeze bottle or brush. Okay, so if there is refrigerant escaping through that suspected points, it will produce bubbles at the leak sites. If soap solution is applied, it will produce bubble. So by identifying this bubble formation, we can conclude that there is a leakage. So that is a method of detection of leakage, but it won't be that much effective if the leakage is very small. Okay, So it is in that much effective in case of small leakage. Second one is halide torch. Halide torches. So you know what actually halide is? Halide means its composition is halogen. It consists of halogens. Halogens means chlorine, bromine, such kind of elements, right? So naturally, the refrigerants are made of refrigerants may consist of chlorine, right? Consist of chlorine. So if you expose this torch flame to that suspected site, torch flame, this torch flame turns green. If it turns green, if the torch flame when exposed to the suspected leakage, if it turns green means there is a leakage, because it turns to green only when it is exposed to chlorine atoms. So that is a property of halide torch. If a halide torch is exposed to chlorine atom, the flame will turn into green. So it means that we can conclude that if the torch flame turns green, then there is a leakage. Okay, but the disadvantage is that any other any other refrigerants apart from CFCs, because only CFCs consist of, or HCFCs. Only CFCs and HCFCs consist chlorine. Other hydrocarbons doesn't contain chlorine. So refrigerants which are apart from CFCs and HCFCs cannot be detected using halide torches. So that is a main disadvantage. Okay. Now we will move to electronic leak detector. Third one, electronic leak detector. So here all electronic leak detectors use an element that is sensitive to halogenated gases. They are sensitive to halogenated gases. Okay, halogenated gases. So an audible or any visual alarm signals when a leak has been detected. That is how electronic leak detector works. Some audio or video signals will be generated. When exposed to halogenated gases, or when a leak is detected, will be generated. Okay, so HFCs, CFCs, HCFCs, all these reference blanks can be easily detected using electronic detector. So most commonly they are used due to their accuracy and ease of use. Okay, so this detector has a filter that prevent contaminants and water from entering it. So only a refrigerant will enter this detector. There are some filters used to prevent the entry of contaminants and water, so that the electronic leak detector can easily detect a refrigerant. If it is mixed with other contaminants and water, there will be some anomaly, because it is not pure. It can only detect refrigerants. Now we will move to fourth one, ultrasonic leak detector. Ultrasonic leak detector. So this system must be highly pressurized for detector to work. Okay. So the refrigerant leak detector uses an amplification system which is able to detect the high frequency sound of the leak based on high frequency of the leak. It works based on the high frequency of the sound of leak. High frequency of the sound of the leak. So when there is a leak happening in a highly pressurized system, there will be a high frequency sound produced, and this high frequency sound will be detected by this ultrasonic leak detector. So this can be applied only in case of highly pressurized system. Okay. So another common method is that detecting using ammonia. Using ammonia. So ammonia can be detected. For detecting ammonia. So if ammonia is a refrigerant, you can use phenolphthalein paper. Have you heard of phenolphthalein paper? You might have studied in your higher secondary classes. Phenolphthalein phenolphthalein paper can be used to detect ammonia. This phenolphthalein paper can be used. The use of this phenolphthalein paper where the moistened paper will turn pink, okay, pink when in contact with this gas. So this if this phenolphthalein paper is placed or exposed into the leaking point, it will turn pink. So this phenolphthalein paper turns to pink color if it is exposed to ammonia gas. Okay. So another method is by using a lighter sulfur candle, which will give a thick white smoke when it encounters the ammonia gas. Okay. So another method is sulfur candle. If sulfur candle is exposed to this ammonia, it will turn to a thick white smoke will be produced. Thick white smoke will be produced. So these are the methods of detecting refrigerant leakage. Okay. Now we will move to another section called charging of refrigerant. Charging of refrigerant. So here, so what is charging? The charging is adding the refrigerant. Refrigerant is being filled into the system. So we have a diagram for how the working is happening. Okay, showing how the working is done. So students, this is the diagram showing the working of or the diagram showing the charging of a refrigerant into the system. Okay, so charging is nothing but adding refrigerant to the system. Adding refrigerant to the system. Okay, so here have a look at this diagram. So I will explain you the step by step how to charge the refrigerant to the system. I will I will tell you the sequence of operation. Before that, you just have a look at this. So this is the compressor to condenser to expansion valve. Sorry, in between expansion valve and condenser there will be a receiver and to the evaporating, and this charging is done through the charging is done at this point. Okay, at this point. So we have a reference cylinder available. So where the reference is pressurized inside a cylinder, and this cylinder is connected with a connector to the inlet of the compressor. Okay, to the inlet of the compressor. So there will be a number of valves which can be used to regulate the flow or control the flow. Okay, so there will be a valve here. So these V1, V2, V3, all are valves. Okay, so first of all, the sequence of operations starts like before charging the air has to be before adding refrigerant we have to remove all the air present inside the system. That is called purging. Purging means removal of air. Removal of air. So there is a purging line here. Have a look at this. Purging line. Purging line is a line through which, or the pipe through which air will be removed. So before charging, the air has to be removed. How to remove the air? So for removing air, do one thing. First of all, we have to shut down the output from the compressor by closing. We have to shut down the output of this compressor. So we have to close this valve 1. So close valve 1. Okay. Now close the refrigerant inlet valve V2. Okay. So this is the refrigerant inlet valve from the cylinder. So close this V2 and V1 is also closed. Now open the valve V3. So V3, open this valve. Open this valve. Okay. Also open the valve to the inlet of receiver. So V1, V2 closed, V3, V4 open. Okay, both this open. Okay, then what happened? But now start the compressor. Okay, now start the compressor. So what happens if compressor is start? There is no refrigerant as of now, only air. So if there is any air, the air is, since this V2 and V1 is closed, if any air is present in the condenser, receiver or evaporator, since V3 is open, this and compressor starts working, the air will move to the compressor, and from the compressor output it will get rejected through the purge line, because this purge line valve should be open. Okay, V5 should be open. If V5 is opened through the purge line, any air through this system get purged through that purge line. Okay, so that is purging. Now after purging, what should be done? Now we have to close all those purging lines. Okay, so switch off this wall or close this wall, close this. Now you should close this purging line wall. Okay, now for charging the refrigerant, open the cylinder valve V6. Now you have to open this cylinder valve V6. Okay, so this is the cylinder valve. Now the cylinder will from the cylinder refrigerant will start to flow. Okay, and you have to stop the compressor motor. Okay, after purging. Okay, sorry, before starting the refrigerant charging of refrigerant, we were purging the air, right? We were removing the air. What happens when air is removed? Air is removed means you are continuing the compressor. You are continuously switching on, the compressor is switched on, right? Compressor is continuously working, means air is being pumped out from the system. Then what happens to the pressure inside the system? It will since the air is continuously removed, some vacuum is produced in the system, right? The vacuum is retained for 30 minutes. You have to retain the vacuum. How vacuum is produced? Because continuously pumping out air. If you continuously maintain vacuum for 30 minutes, it can be concluded that air, then only it will be air free system. Okay, it can be concluded that. So that is very important. You have to retain the vacuum for 30 minutes. So after purging air from the system, the connections are tightened and the valve V3 and V4 should be closed. So you don't need to switch off the compressor. You just turn off V3, and V3 should be closed and V4 should be closed. Okay, close V3 and V4 and open the cylinder valve V6. Okay, if after closing V3 and V4, open the valve V6, and now refrigerant will slowly, since compressor is switched on currently, the refrigerant will slowly flows through this valve V2. Okay, and V2 valve should also be open the cylinder valve V6, and the compressor suction valve V2 should also be open. So this is V2. Okay, this V2, you open the V2 means it will be sucked into the compressor. This V5 should be closed. Okay, since and stop the compressor when the sufficiently high quantity or the required quantity of refrigerant has entered the system. You can stop the compressor. Okay, after stopping the compressor, you can close V2 and V6. Okay, so now refrigerant is completely added into the uh, compressor. Okay, so if sufficient quantity of refrigerant has entered the system, now you can close this V6 and V2, and now proper working of VCR system can be started. So the quantity of the reference charge in the system can be observed by noting the difference in, you can note the difference in the weight of the reference cylinder before and after charging. So you can have a calculation, or you can identify the quantity of the reference charge into the system. So the amount of reference to be charged is depend on the size and type of insulation of the system. Okay, for small installation of water cooler, sorry, type of installation of the system. For small installation like water cooler, room cooler, such thing, the exact quantity is prescribed by the manufacturer. If the recommended weight of the refrigerant is not known, the refrigerant is charged in the system till no flashing or bubbles are visible in the liquid line. You will have a sight glass in the liquid line, so you can, if no flashing or bubbles are formed, you can add refrigerant up to the point where there is no flashing or bubbles are visible. Okay, so this is how you charge a refrigeration system. Now we will move to some refrigerant control system. Refrigerant control system. Refrigerant control system. These are devices used to control the flow of refrigerant. Okay, these are devices used to control the flow of refrigerant at various points through the refrigerant cycle. Okay, so there are 6 basic types of refrigerant flow controls. First one is automatic expansion valve. Automatic expansion valve. Now this what is automatic expansion valve? We have studied. We have studied in it is nothing but an expansion valve. Expansion valve. We have studied in expansion valve in the previous sessions. The next one is thermostatic expansion valve. Thermostatic expansion valve. That too is studied in the previous session. Third one is capillary tube. Capillary tube is another expansion valve. So all these expansion valve are used to control the flow of refrigerant flow. Okay, refrigerant flow. Capillary tube, low side float, low side float, low side float. 5 high side float valve. This type of float. So you have studied the working of or construction of these 5 different valves in your expansion in the session in which expansion valve are dealt. So you have already studied, and you have studied the working or the function of these valves are nothing but reducing the pressure as well as controlling the or regulating the refrigerant flow to the evaporator. Okay, refrigerant flow to the evaporator. So apart from this system, there are another other control systems like thermostat. So have you heard of thermostat? Thermostat is nothing but a temperature controlling temperature detecting system. So thermostats allow refresher system to bring product down to a predetermined temperature, but not lower than the temperature. Okay. So maintaining temperature, it helps to maintain a predetermined temperature. Maintain a predetermined temperature. So thermostats allow refrigeration system to bring products, the products to be cooled, to bring that temperature down to a predetermined temperature, but not lower than that temperature. So thermostats typically are located inside the fridge behind the interior walls with a sensor extending into the cooling compartment. So thermostat sensor will be present in that cooling compartment, but it actually is, the sensor is present in the cooling compartment, but the as a whole, the equipment is device is located inside the fridge behind the interior walls. Okay. So these refrigeration thermostats are similar to room thermostats in that they use a bimetallic strip to sense temperature. They use a bimetallic strip. A bimetallic strip. Bimetallic strip is used to sense the temperature. The thermostats don't often fail completely, but their internal calibration sometimes changes due to some factors. Okay. So this the working of thermostat and all you may be already knowing, okay, how it works. So you might have studied in your metrology, right? Thus, it is not safe to assume that the temperature indicated on the thermostat is the actual temperature, but it will give an accurate measure. Okay. So so another important control is defrost control. Defrost control. Okay. So defrost control, where cooling is the actual goal of refrigeration. Where cooling is the only refrigeration goal, not freezing, only cooling. Okay. Special defrosting equipments may be required in such cases, because when liquids are cool, sometimes there may be chances of freezing. That is frosting, freezing or frosting, same. So if it is not actually required, it is not actually required. That is, it is not actually. We only require cooling, not frosting. In such cases, there may be some requirement of defrost control systems, because the refrigerator space temperature is above freezing, allowing the evaporator fans to run when the compressor is off. Maybe all that is needed to remove the frost. Okay, so where freezing is the goal, however, heat from the some same source or some source must be periodically applied to the evaporator coil to melt the accumulated frost. Okay, so these defrost cycles are often initiated by timers. So this is appropriate, but using a timer to establish the duration of the defrost period tends to waste energy. Okay, so evaporator temperature is a better indicator of when to stop defrosting. So have you understood how defrost is working? So in order to defrost, you just need to switch off the compressor compressor should be switched off. Compressor is switched off for a particular period of time, and this expansion valve, so some sorry, an evaporator fan will start to work. Evaporator fan will be on, but compressor will be off. If compressor is off, means there won't be any circulation of refrigerant. Mm, the the refrigeration may not take place. If refrigeration is not take place, means the temperature of the system, the temperature in the evaporator slowly start to rise, so that the frost will be removed. Okay, so evaporator fan will be working, but compressor is switched off, so that frost will be removed. To remove the frost, we just need to increase the temperature slightly. Okay, so there will be some timers based. These defrost cycles are often initiated by timers. Okay, but using a timer to establish the duration of the defrost period tends to waste energy. Why? Because sometimes the removal of frost may be taking place within very short span of time. So, but if some timer is set for some certain period of time, the chances are there for wasting of energy. Okay, so the evaporator temperature is a better indicator of when to stop defrosting. So instead of timer, you just need to find or identify the evaporator temperature. If the evaporator temperature is increasing a bit slightly, it means the frost is removed. Okay, that is how defrost control is done. Now another final control system is head pressure control. Head pressure control. head pressure control. So head pressure refers to the pressure in the high pressure side of refrigeration system. That is condenser pressure. Condenser pressure. Condenser pressure is the head pressure. So it may be also referred to as the discharge or condensing pressure. Okay, the temperature at which refrigerant condenses in the condenser is known as the condensing temperature. Okay, so lowering head pressure reduces the temperature at which condenser operates and increases the efficiency of the refrigeration system. By minimizing the head pressure, we can maximize system's cooling capacity, right? So by minimizing head pressure means we can decrease the condenser temperature and thereby increasing the efficiency of our system. Okay, so by minimizing the head pressure we can maximize system's cooling capacity and minimize energy cost. So when head pressure is higher than the necessary value, the compressor has to do more work, so more energy will be consumed, so it will therefore use more power and its efficiency will be decreased and cooling capacity will also be decreased. So the compressor has to run for longer to provide the required cooling and won't be able to provide enough cooling to achieve the required process or storage temperature. So minimizing head pressure saves energy, right? So we have to minimize the head pressure so that energy can be saved. Also maximize the cooling capacity of the system. If the refrigeration system has head pressure controls, we may be able to lower the head pressure by reducing the set point. Okay, in all the cases, the head pressure was controlled by switching on or off the condenser fan. So condenser fan helps to control the head pressure. So with this, we will stop the fourth module. We have completed the fourth module. So don't merely depend on these videos only, because I was trying to giving only a small brief about all these components. So there may be a lot of points to be read from the textbook. So I humbly request all of you to read certain textbooks so that you can get a wider idea about all these things. So solely depending on these videos only won't benefit you that much. So you should be reading widely. Okay. So with this, I'm concluding this fourth module. Thank you.